Hello everyone. Good evening. I hope I'm audible. Just give me a minute. I'm setting up the things here, guys. Hello. Just give me a minute. I'm setting up the things here. Hello, Shubham. Good evening. Okay. So, hey, Divakar, thank you for confirming. ऑडियो इंक्रीज करूँ थोड़ा ज़्यादा हो जाएगा वैसे चलो ठीक है आई हैव इंक्रीज्ड अ बिट ऑफ अ वॉल्यूम but anyway do let me know if there is any concern चलो ठीक है guys so I think let's start that's good that already we have people around so as always it's pretty much a live session so any questions anything in between please feel free to ask me more than happy to help but today our intention is to talk about some core skills which is needed to start your data science journey okay so we have been talking about a lot of concepts so we have been discussing about some of the methodology in regression and the classification techniques like the classification indexes we talked about precision recall a lot of other things but now today we'll just list down few of the core technical skills apart from machine learning and whether machine learning is a mandatory skill or not and we'll try to find out what are those mandatory skills for me which are needed at most to start my career as a data science guy okay and in fact in data science also there are so many designations available like data analyst business analyst and all that so we have already discussed about all those roles but again in general, if you have to start your career in data science, there are still few mandatory schools, mandatory skill sets, which I think you should be good at, which will definitely help you to start your career. So that is what we will be learning today. So I'll try to give you an outline of all of those different skills. But from next class onwards, our intention would be to go a bit deep in each of these skills one by one. And then we will try to understand how they play an important role in terms of our day-to-day activities. Okay, so that's pretty much what the agenda is. Cool, guys. So stepping forward, moving ahead with our agenda for today. So, but before that, you know, my name is Arpit Jain and I am here in front of you because data science is my true passion and I really like sharing my expertise with people. And also I have around 10 plus years of industry experience where I've been working with multiple different organizations. And along with that, I'm also a motivational speaker. So do talk to students. I do talk to them regarding their career placements, jobs, in general questions also. So anything which you want to talk about, please feel free to reach out. Always happy to help. Okay. So, and it's pretty much a live session, guys. You know it. So try to utilize that time. And then if you have anything in general also, obviously, if anything is from the concept, please please feel free to share that. In general also, any concerns, please try to put up in the chat. So we'll discuss. Moving ahead. So today we will be talking about these two main things. So first, we will talk about the key skills, which is more like an overall skill needed to start your data science journey. So that definitely includes my technical skills. So this will be including my tech skills plus my my soft skills as well. In terms of my overall agenda, but now we will further go a bit deep here in the technical skills part. We will try to debug or try to take 4 different core skills as well. So that shall be comprising of say Python, coding languages. So basically a coding platform which is needed for your day-to-day data science activities, some techniques like statistics, machine learning. So we will go a bit deep here and we'll try to understand what are those 4 different technical skills also needed to start your data science journey. But having been said that, guys, we have to first understand that when I say data science, it is going to mandatorily include the coding part. So always remember one thing. I have been discussing around with a lot of students, and there is a myth revolving around in students where they understand data science from bit of definitions perspective, like more like a basic definitions, like what is this and what is that, and more like a superficial definitions of things. But guys, it's not only about understanding the basic definition. Understand that when you're into data science part, you're actually trying to implement something for your business, right? And that implementation is only possible if you are actually doing things on some of the platform. So implementation is technically feasible when you are actually coding somewhere. So when you're doing something, when you are trying to apply it, coding becomes a mandatory requirement. And by coding, I'm not saying that only Python or some other thing is going to be only going to be that platform on which the development can happen. Basically, in data science, there are a lot of other platforms also, other coding platform also, in which I can develop the machine learning models. You might have heard of something called as R. There's something called as SAS, right? So there are a lot of other platforms also in which the data science jobs can still be done, right? But now on top of all of them, we have to prioritize the skill definitely which is of utmost important. I cannot be good in every single thing. I'll become a superhuman if I become good in every single thing, right? So that is practically impossible to expect. That is inhuman also to expect from somebody that you become good in every single thing. That is practically impossible, right? So that is where we always talk about the mandatory skills, and then we talk about some additional skills. So I'll try to list down those 4 mandatory skills first, and then eventually we'll also talk about the other things which are additional. So apart from these 4 core technical skills, what are few things which are additional? Like if you know them, that'll become an advantage for you. So we'll talk about that as well. Okay, so that's pretty much what the agenda for today looks like. Moving further, first, your code for the day. So again, data is the language of the power holders, right? So I think it's a spelling mistake, of the power holders. So we again talk about something where data holds the power of taking decision in any business, right? So we have been talking about data being the new fuel and whatnot, right? So what data has enabled in any industry is basically given the power to the right people to take a strategically correct decision depending on what your data talks about. So what is your current trend? What is the customer's expectation? What is the overall journey of your problem statement? And then eventually based on that, you are able to take a strategic decision. And in fact, you being a data science guy, helping your business to take that strategic decision. And that is where the power of data comes. And it is a language of the power holders who are actually at the governing position. So the people on the top, they are completely relying on what data is telling them to take the decision in their own organizations. So that is where we always say that now data is having that power where you can drive the business towards your own success areas. So data is the language of the proper power holders in any organizations. Moving ahead, now we'll quickly talk about few of the key skill sets which is required in analytics. And mark my word, guys, here we will try to cover both the technical plus soft skills. So we'll try to talk about both of them, technical as well as the soft skills, because in analytics we not only talk about the technical parts, because you have to understand, like when you're talking to some of your clients, when you're trying to understand the problem statement, the understanding is you're trying to get to know the pain point, and based on that, once the technicalities has been done, you're trying to deliver it to the same customer. So how you're going to present it to that customer, how you are able to understand it from them, all of these becomes important. If you are not reachable to them, if you're not able to understand what they're saying, and if you're not able to present what you have developed as a solution for them, obviously that is not going to have a good impact in your business. So both the things, technical plus soft skills, becomes equally important in my analytics field, but that's what we're going to talk about, the amalgamation of both of them today. So I'm going to remove the ink and then we're going to start. So very first thing, guys, which is mandatory for you to start your career in data science is practically saying about analytics mindset. So there is a keyword called as data wrangling. We also call this as data munching. We also call this as data analysis, or we also call this as data cleaning, and in simple terms we call this as EDA, or exploratory data analysis. So intent here is to basically explore what we have in our data. So data wrangling, data munching, data analysis, data cleaning, all are some or the other way part of the same process which we are calling as EDA, exploratory data analysis. So guys, this is your first key skill sets which is required for you to become a good data science guy. You need to have eye for the smallest of your details. So exploratory data analysis, it is going to expect you to find out the hidden trends, the hidden information from your data. So you might have heard of some fancy terms such as missing data cleaning. Then we have something called as outlier treatment. Then we have something called as correlations check. Then we also talk about univariate analysis. Then we talk about bivariate analysis. So all of this is some or the other way part of my EDA. All of this are actually comprising as one of the other methods of EDA. So EDA is a very broad term. When I say exploratory data analysis, that means that my intent is to explore what I have in my data. And when I explore in my data, I'm talking about the missing data, I'm talking about the outliers, some way odd values which I have. I'm trying to check the correlations between maybe my independent feature sets or maybe my target with the independent feature sets. I'm also talking about my univariate analysis, one by one variable analysis, or my bivariate analysis. Or we also talk about in advanced state, we're going to look this as feature engineering steps. For this, we have two things. First, feature extraction. Second, feature reduction. And even these are pretty much part of my data wrangling or data cleaning step, because suppose I have a feature set, say date time. I have some date and time component in my data set, and from this date time component I want to find out what is the hour part, what is the minute part, whether that day is a weekday or a weekend, what is that day of the week, which year it belongs to, right? So I have one single column which is date time, and from date time we are extracting multiple smaller pieces of information which also could play an important role. That is called as feature extraction, feature engineering. Vice versa of this situation, I have say 100 odd features, and from those 100 odd features After doing all the analysis, I figured out that, maybe 60 or 70 are useless. And obviously I cannot straightforward say with 60, with 70 are useless. There's a lot of statistics involved in that. So the process of reducing my number of features to a standard number is again called as feature reduction. So both of them again becomes my primary part of data wrangling itself. So data wrangling, it involves a lot of important things. First, we need to have eye for the smallest details. We need to understand the data structures, because data could also be in different formats, maybe in a simple text file, maybe in a log file, maybe in a CSV form, maybe from a web page, HTML file, XML file. So we need to understand the different data structures. Post that, data cleaning becomes very important. So we have to talk about the data cleaning, we have to talk about the feature engineering, and then the hidden insights. So all of this is intended to have the hidden insights from my data. What are my crude information which can actually help to take some business relevant decision? That's where the intent is, to find the hidden insight which is not visible to a naked eye right now, right? And this whole part of my analytics mindset. That's where we say that, yes, analytics mindset is what is helping us to find out the relevant details from the data perspective. So having an analytics mindset obviously is going to help build up the things here. So analytics mindset is definitely one of the core thing which is required here. Clear? Any questions, guys? I hope you are able to understand what is analytics mindset. And guys, when I say analytics mindset, it is not like a pill that you're gonna eat it today and you're gonna be good in analytics mindset tomorrow. That improves with time. More problem statements you see, more data sets you see, more problems you solve, right? You start developing that eye for that details, right? So intent should be that first you need to look forward to these 5 steps: missing data, outlier, correlation, univariate, bivariate. Post that, we're going to look at these 2 things as well: feature extraction, feature reduction. That's pretty much gonna part of my analytics mindset, my EDA process here. Cool. So I'm erasing the ink here. Moving ahead, after my analytics mindset, we are going to talk about the data visualization skills. So data visualization skills are also equally important here. We need to look forward to this data visualization skills as well. So again, imagine whatever analysis we are doing, whatever hidden information we're trying to find out. So we have so many data points, so many numbers available, where if I try to understand things from a simple numbers perspective, it becomes next to impossible for us to simply understand what is happening in the background. That is where the data visualization skills comes into picture. So from a data visualization perspective, what I mean to say is, you need to understand how this can be improved. And then when I say data visualization, so ultimately I need to have the sense like what graph to be plotted, which graph should be used to find out the relevant information which I'm going to look at from the data. So respective plot types, and from those individual plot types, my intent is to have the powerful insights from those plots. And ultimately, my intent is to find out the hidden relations from these powerful insights. What do we have? So when I say the EDA process, when I say the univariate analysis or the bivariate analysis, so that EDA process is anyway going to be comprising of my plot. So EDA, if you remember, we have something called as univariate analysis and bivariate analysis. So in this univariate and bivariate, by default, the data visualization skills are included, because when I say univariate analysis, I am talking about distributions. That's where maybe a histogram plays a very important role. And when I say analysis, I'm talking about multiple different graphs. So maybe a scatter plot, or maybe it could be a box plot, maybe a category or a number would be important. So likewise, we have so many graph options available inside each of these different types of analysis. So we need to develop this sense where I can say that yes, from these individual graphs, we should have an eye to the details and find out the powerful insights, the hidden relationship between each of the variables from the visualization stats. Right? So all the hidden relations from this, the influencing factors. So suppose now I have a target, suppose say sales. I know that if I plot a graph between my sales and say number of units. So I know that if my number of units is somewhat say increasing, so I'm seeing maybe an exponential increase in my sales. So I'm plotting a kind of a scatter plot, and from this I'm trying to find out the hidden trend or maybe a line plot. So from this what I'm seeing, if my number of units is increasing, I have an exponential increase in my sales. Right? So some sort of this hidden trend identification from the available data set, that's where the EDA process comprises of my visualization part, right? So visualization is basically again part of my EDA. EDA is a bigger umbrella here. When I say EDA, EDA is a bigger umbrella, exploratory data analysis, that comprises of the statistical analysis based on all those numbers, plus the data visualization part that is going to involve the univariate as well as my bivariate graphs. So a lot of different options are available, and from all of these different options, how I am going to leverage the data which I have, pretty much part of my core skill. So guys, again, any questions, please feel free to put up. Moving ahead is where we talk about the algorithm part. So we have analyzed our data, and from this analysis, I have figured out maybe, yes, this is the right pattern between my two of the data points and between my feature set and the output, right? And that's where we have machine learning to generalize this now. So machine learning is the methodology where a machine can replicate the learnings. For example, again, similar thing which we have been discussing so far. Suppose that I'm going to a doctor, and doctor is, I have certain disease basically, which I even don't know what is that. And I have done some basic reports, and I'm going to the doctor. I'm saying that, okay, this is what my symptoms is. So 10 symptoms and maybe some relative, blood reports and some other reports. So now what doctor is doing, he's trying to analyze all of these different information, which is pretty much the symptoms, and also trying to understand what exactly is happening in terms of my reports. And then the combination of these two, the doctor is able to come to a conclusion that, okay, this patient has this disease XYZ. So finding the trend and the relationship between my different independent values, correct? That's where the concept of machine learning comes. So similar thing, what doctor did, trying to see the pattern and tell you, okay, this relates to a disease A. Right? Similarly, that's what machine learning tries to do. So it is trying to solve one single problem statement at one time, but for that, it is trying to conceptualize and trying to build up the rules, or the more like a algorithm where based on these certain procedures and the rules, it is trying to identify, okay, based on this and this and this parameter, this is the output. That's where the concept of machine learning comes, and that becomes one of the core key skill for you to start your analytics career. Obviously, machine learning has lot of different subparts, which is again where we'll be talking about, where we were actually talking about understanding my regression problems, supervised learning, unsupervised learning, right? So all of these are becoming my subparts of my machine learning, and that is becoming my one of the again core key skills for my starting of my journey in data science. Post this, we talk about data science level coding. So let me be very upfront with you. Yes, coding is involved in data science, so we have to be good in coding. So whatever we are going to develop in data science is prominently going to have some or the other platform dependency on top of that. Otherwise, how am I going to develop something? Just imagine that. How am I going to develop something? If I'm going to develop a solution, I need an environment, I need a platform on which I'll be developing. Correct? And that is a place where coding comes into picture. That is a place where Python comes into picture, and that's where we try to understand how exactly we use this for our own benefit. So when I say data science level coding, so there are certain prominent platforms where the development of data science can be done. So Python, R, SAS becomes one of the three major platforms which are more or the other way used in data science industry. So obviously we have to then prioritize, we have to understand whether I should go with Python, whether I should go with R, or whether I should go with SAS. As simple as that. So let me give you a straight bifurcation, at least at this stage, okay, right now. So if there are say 100 jobs in the market, if not 95, approximately 90 will be focused on Python. Out of 100 jobs, 90 will be almost focused on Python related platforms. So companies, out of 100 jobs, 90 companies will be having the solutions built up on Python. Why Python? Why only Python? There's a lot of reason for that. Obviously, Python has a lot of advantages compared to other languages, so we are not going into deep right now. But definitely out of 100, 90 will be focused on Python. 5 might be focused on R, and other 5 might be focused on SAS. Having this distribution in mind, definitely Python plays a very important role in your selection process. Probability wise, Python is definitely important. Right? So with this part, we have to understand Python becomes again one of the core skills required to start your analytics journey. So it becomes one of the mandatory skills for you. At last, we have the business domain knowledge. We are going to talk about the business domain knowledge. And in this business domain knowledge, obviously, imagine why business domain is again important. You're solving a problem, suppose in a healthcare industry, say again, cancer detection problem or some other healthcare industry problem. But you imagine you are not from a healthcare domain, you are from say finance industry, you are from probably a bank, right? So do you think being from a bank or being from a financial institution or other industry, you can solve the business problem from healthcare? Technically, yes. So even we have a catch here, technically, yes, but we might miss out the core domain level details which we are not aware of. So obviously, if a person who is dedicatedly from a healthcare industry, he might be knowing some inner details like the technical jargons which we, not being from that industry, we are not aware of. That could happen. So obviously, business domain plays again an important role where it adds an added advantage to your model. It gives an edge to your model. But again, take it from me, it is not always a mandatory requirement. It is always an added advantage, but it is never a mandatory requirement for you to become a data science guy, but always an advantage, right? So again, this domain knowledge becomes one of the key skills to have your career started towards that area, right? So now with this, we'll quickly move towards the 4 core technical skills now, guys. Understand. So we have been talking about both technical as well as the soft skills. Now, if we have to prioritize certain core technical skills, how should I start my journey? So in short, there are 4 technical skills for you which are mandatory. When I say mandatory, that means you are supposed to be good in this. You cannot be bad in this. Anything additional apart from these 4, like say Tableau, Power BI, Big Data, Hadoop, Spark, cloud services. So many things are there. In fact, not only this, there's so many other things as well. So anything additional which you can think apart from these core technical skills becomes my additional advantage. So Amisha, to answer your question, no, DSA is never a mandatory requirement. DSA is basically an additional skill for your advanced researcher roles in data science, right? It's never a mandatory requirement as such in DSA. But so I'm not talking about the core DSA. In fact, in Python as well, we have few data structures which can solve your jobs in any of your data science problem services. So we will be discussing in detail towards that area. But if I have to list down the 4 mandatory skills to start your career in data science, that is going to be SQL, Python, machine learning, statistics. Now, a lot of people will ask me, how come SQL and why SQL is a core mandatory technical skill for me? So these 4 guys are my 4 mandatory skill. Okay. So SQL, Python is one of the mandatory skill to start your career in data science, guys. So always remember that. But again, why SQL? And I hope you are also pretty much aware of what is SQL. I'll also go in a bit of a detail here. But understand why SQL. In fact, we'll go in SQL. So here, if we talk about these 4 things, so top 2 like SQL and Python, they become my coding details. These are my coding languages, and these 2 are theory. So basically 2 coding language plus 2 theory subjects. These are my mandatory requirements. Okay, SQL, Python, machine learning, statistics, these all become my mandatory requirements. Let's go a bit deep in one by one of them. So first, SQL. What is SQL and why SQL becomes a mandatory requirement for me to start my career in data science? So SQL stands for structured query language, and we know that SQL is nothing but a platform which enables us to interact with the databases. But why do we need to access the database? See, I've told you, being a data analyst, being a data science guy, you are prominently working on data, right? And in industries, we do not have data straightforward available for us to start working on. We might, because in industries, the data is actually prominently available in my databases. So we have to interact with the databases to get the data first, on which we have to actually solve the problem. And if we do not have the data, how can we expect ourselves to solve the problem on data, right? So the first requirement for us to do any data science level problem solving will be to have the data first. And for that, getting the data, SQL becomes a mandatory skill, because SQL is that platform which is enabling you to interact with the databases and write some queries and get some actions done on which you will be able to extract the data for your own need, right? And that is where SQL is that platform which is giving you then access to work on those databases. And when I say work on those databases, there are multiple actions which we can actually perform on databases. That includes the data definition language, data manipulation language, the TCL transaction control language, DCL data control language. So there are 4 different categories of jobs which can be performed on databases. And based on these categories, we have 4 different types of SQL languages. So DDL commands, DML commands, TCL and DCL. So DDL stands for data definition language, where we are trying to play around with the structure of my tables. So because we have a concept of RDBMS in SQL, Relational Database Management System. That's simple. In simple terms, try to understand this from a tables perspective. So RDBMS is nothing but a structured table where we have the data in form of simple rows and columns. Simple rows and columns, that's pretty much what RDBMS means here. So RDBMS, where we're going to talk about simple rows and columns. Of tables, we are going to have this. And also, based on this, we have certain actions which can be performed. Suppose I have to design the schema, design the layout of my structure of the table. So DDL command. DML, I have to extract some information. So basically, whatever data points are inside that table, I have to do something on top of that. Maybe rename, delete, add, rename, or extract. So all of this pretty much manipulating my data. So data manipulation language. So TCL is a transaction control language and DCL is the data control language. TCL and DCL are more subjective towards a data administrator's role. So being a data science guy, our job will be 95% focused towards DML, data manipulation language, which we will discuss in detail with time. Second very important key skill which I was talking about is Python. Right? So Python is again another very important key skill. So why Python? Why only Python and why not anything else? And what is that benefit we have in Python? So Python in fact is a very popular programming language, not only limited for data science roles, because it is a pure developmental platform which can be used for software development, web development, system scripting, mathematics, so many different areas in which Python can be used. And data science is one of those areas in which Python has been proven very effective, because Python provides you so many different APIs, high-level APIs, or in simple terms, we call them as libraries, which is able to solve the day-to-day activities or day-to-day problems from data perspective. Like talking about the cleaning process, talking about the build-up process, the model side. For everything, we have high-level APIs coming up into picture, and Python gives you that flexible environment, which is very much easy to be worked on. Right? So that's pretty much what Python is looking for. Obviously, Python is based on the OOPS concept, that is nothing but object-oriented programming. So in object-oriented programming, there are certain things which we're going to talk about called as inheritance. There are 4 pillars of OOPS concept: inheritance, abstraction, polymorphism, and encapsulation. There are 4 pillars of OOPS concept. We call them as 4 pillars. So these are my 4 different things which is kind of important in my OOPS concept on which Python is structured upon, right? And also Python has some inbuilt core data structures in terms of lists, tuples, dictionaries, set, a lot of other things are there. So we will be talking about all of them one by one, certain core data structures and how each of them plays an important role in defining the Python query. So we will be discussing about that as well. Post this, third major technical skill is machine learning. So as the name also suggests, machine learning, I'm making sure that the machine is getting learned of something, right? So machine learning in simple terms is nothing but where we talk about we have certain general trend which we are trying to trying a machine can learn, right? So we're trying to make sure that the machine is able to identify those hidden patterns, and that is from where it is able to do the forecasting of things in future. A lot of different things are there. We talk about pattern identification, we talk about trend prediction. So all of them is pretty much subdivided into different types of problems. We have already discussed about that. Supervised and unsupervised. In supervised, we have labels. And in unsupervised, no labels are there. We don't have any labels. And in this, it can be further subdivided into 2 types, classification and regression. So in classification, where the output is more in terms of 0, 1, more like a class. And in regression, we talk about continuous number. So that's how classification and regression problems are being built up. Unsupervised, that's where we do not have any labels. So we are prominently going to talk about, say, clustering approach here. More like customer segmentations. Talk about recommendation engine. These are pretty much needed in terms of my unsupervised method. And again, we will be going in detail of unsupervised as well. No, so Naheem, just to answer your question, so AI is again a bigger umbrella. So basically it works like this. So I have a bigger umbrella, which is say AI, and ML is sub part of AI. And inside ML, we have deep learning. So that's how the AI has been structured as. So AI is basically of 2 types, strong AI, which is nothing but robotics. It's a pure research field. Second is weak AI. That's where we talk about a single problem, or machine learning is an example of weak AI. So machine learning is sub part of AI. It's not like you need to have more knowledge of AI. It's not a separate ball game altogether. So AI is of 2 types, strong AI and weak AI. That's where in strong AI, we talk about multiple problems at the same time, more like a robotics. Machine learning, we talk about single problem at one point of time. So more like classification, regression problems. So it's more like a part of AI, okay? And at last, we talk about statistics. Statistics is way beyond mean, median, mode. So since our old days, we have been in this mindset that statistics is nothing but mean, median, mode. Okay, so we have to understand how exactly things could be working for different parts of my stats. So it's way beyond mean, median, mode. That's where we talk about the core concepts of EDA, all the different exploratory data analysis. We also talk about hypothesis testing. That's where we have certain tests based on the data types. So it's something called a Z-test, T-test, chi-square test, a lot of different tests are there. We are going to perform how good or how probabilistic my particular event is for it if it has to happen. So all those hypothesis testing comes into picture. Variance bias, what is the variance in my data if I'm putting any bias in terms of training? So A/B testing, variance bias test, again pretty much part of my statistics. Again, few advanced topics might also include feature engineering, feature reduction, like principal component analysis. A lot of things are there. So again, statistics becomes the core of every single data science problem, right? So these four combinedly becomes very important for you to start your career in data science. Take down this. So Python, SQL, stats, machine learning. These four are my mandatory skill. Anything additional will become your advantage. Cool, guys. So this is what I intended to cover today. I hope that makes sense. I'll go a bit deep. Now I'll take one of the other topics and I'll start going a bit deep in this. So SQL will start about that in our next class. But this is what I wanted to cover, guys. Any questions, I'm more than happy to answer it. Any questions which you want me to answer right now? You can use R. As I've told you, R is again one of the platforms on which you can develop the data science problems. But thinking from the ratio of the job opportunities, Python becomes more probabilistic in terms of you to get a job, right? So if you have to learn one out of two, like R or Python, I would always recommend going for Python. Learning for data science is too much time taking. That is true. So I agree, learning for data science is too much time taking. It is there for every single process. I mean, not only data science. If you want to go to any single field, what if you want to go to a CA line, or you want to become what to say, maybe something else? Do you think it is easy to do anything like that? So you're trying to build your career on data science, right? So obviously it will be time taking. There are so many concepts involved, right? So obviously, yes. So it is time consuming and you need your effort to be put in the right direction. Why it is so hard? Because there is so much of competitions around, and the number of opportunities is also limited in terms of the interns roles and the beginner roles, because this is the kind of a profile where you need to have the eye for the details again. So that's where the beginner level roles and the internship roles are slightly limited, but again, you have to keep on trying if you want to get into this, right? So it's not like it is not there, but yes, obviously it is a bit limited for interns and the entry level roles. Data science resume, yes, absolutely. So data science resume ideally should have the hands-on experience, like it should have few projects on machine learning part, at least 3-4 projects where you could show that you have done something good in data science, right? In fact, I've taken your feedback. I think somebody else's feedback was, I don't remember it. So I'll come up with the class on data science resume. So maybe if you want to share your resume in that class, so we can quickly review it, or maybe I'll show you some random formats. So I'll take up that. Okay, that's fine. I mean, it's completely okay if they find it easy. So it is very subjective, Amrit. Okay, so it is very subjective. Which is better to use, Power BI or Tableau? So both of these are tools, in fact, having their own respective pros and cons. So I cannot say that this is good or that is bad. Obviously, each of them have their own pros and cons. Power BI is having some advantage over Tableau, but Tableau is more user friendly in terms of drag and drop things. Each pros and cons. I mean, I have worked with both of them. If you ask me, I will rather choose Power BI over Tableau because Power BI gives few more advanced options, but Tableau is more simple to use compared to Power BI. Any other questions, guys? From which platform we should practice Python for data science? So there's so many platforms. So Lead Rank, CodeChef, so all of these are good websites. So it's not like Python according to data science, it's about learning Python first. So all of these are standard websites. So if you can practice questions of Python for data structures, that should be fine, because Python coding for data science is nothing. There are certain libraries which you're going to use. That is pretty simple, but the coding rounds will still be prominently focused around the basics of Python basically. Naheem, to answer your question, yes, obviously having a knowledge of cloud services, it's always an added advantage. In fact, I told you, so anything additional apart from these 4 core skills becomes your advantage. So obviously having the knowledge of cloud services is going to be a biggest plus for your resume, but not at the cost of these 4 mandatory skills. If you are sure that you have covered these 4 skills, you can go in any direction, right? So there's an ocean in front of you. Cool, guys. So lovely. Thank you so much for asking so many questions. So we will meet again the other day, and then we will go a bit deep in other concepts. So prominently towards SQL, and that's where we are intended to start with. Cool, guys. Thank you so much for being patient and listening to me. So see you the other day where we'll go a bit deep in SQL. Thank you so much. Have a good day ahead. Bye-bye. You can, right? So there's